Ever wonder how scientists predict stock market crashes or groundwater levels? It's not guesswork, it's a blend of math, data, and smart modeling. Today, we're unpacking a groundbreaking approach, Bayesian models for joint feature and lag selection. This technique is revolutionizing forecasting in finance, environmental science, and beyond. Let's dive in. Imagine predicting tomorrow's weather. You know today's temperature, humidity, and maybe yesterday's data. But what if the weather today depends on the day before, or even a week ago? That's where time series models come in. They use historical data to forecast the future. But here's the challenge: which variables matter? Do you include today's wind speed, last week's rainfall, or the stock market's performance? The answer isn't obvious. This is where the research shines. Scientists are tackling a critical problem: how to select the most important variables and their lags, the time delays between cause and effect, in a way that's both accurate and efficient. Think of it like organizing a messy room. Some items are essential, your keys. Others are just clutter. The goal is to keep the essentials and discard the rest. Here is where Bayesian statistics steps in. These models act like a smart assistant, updating its guesses as it processes more data. The team used spike-and-slab priors, a statistical tool that zeroes out unimportant variables, the clutter, while keeping the crucial ones, the keys. Imagine a spike that eliminates noise and a slab that retains signal. This lets the model focus on what truly matters. But there's a twist. The model doesn't just pick variables, it also determines how far back to look in the data. For example, does today's stock price depend on yesterday's or a month ago? The algorithm tests different lags automatically, like a detective checking alibis to find the most relevant clues. To handle this complexity, the researchers developed a two-stage MCMC algorithm. MCMC, or Markov Chain Monte Carlo, is like a super-efficient search engine for models. The first stage narrows down promising variables and lags, while the second fine-tunes predictions. This approach is faster and more accurate, even with massive datasets. Think of it as a GPS that recalculates routes in real time. The results? Their method outperforms older techniques. In real-world tests, it predicted groundwater levels and stock market trends with fewer errors. Why does this matter? Better predictions mean we can prepare for droughts, manage water resources, or make smarter investment decisions. It's not just math, it's problem-solving with precision. Let's break down how it works. Take groundwater levels in a wetland. Researchers trained the model on 14 years of data, accounting for missing info by analyzing seasonal trends. By studying the previous 4 days, they predicted the next 400. The model matched real-world data 75% of the time. Impressive for a statistical detective. Now here's the kicker. When applied to stock market data, the model adapted like a pro. By tweaking parameters like how far into the future it looks, they found that predicting 5 days ahead balanced accuracy and precision. It's like finding the perfect spice level in a dish: too little, and it's bland; too much, and it's overwhelming. This model, it's just right. But how do we know it's any good? Metrics like mean squared error, MSE, measure prediction accuracy. Lower is better. R-squared shows how much of the data's story the model captures. And here's the secret sauce. Inclusion probabilities highlight which factors matter most. For groundwater, daily rainfall and flow dominate. For stocks, companies like Apple or Amazon consistently rise to the top. The real test. Applying this to real-world chaos. Stock price errors vanish almost instantly, suggesting the market reacts immediately to new info. Meanwhile, environmental data shows rainfall today boosts water levels in days, but solar radiation, not so much. Tools like correlation cross-functions, CCF, and partial autocorrelation functions, PACF, act as microscopes, isolating cause and effect relationships while ignoring noise. So what's the takeaway? This research isn't just about equations. It's about solving real-world puzzles with mathematical rigor. Whether you're a student, scientist, or just curious, understanding these models reveals how data drives decisions in our world. The next time you hear a forecast or market analysis, remember, math is working overtime to keep things accurate. Thanks for watching. If you found this intriguing, hit subscribe for more deep dives into science and tech. And drop a comment. What's one thing you'd love to predict with better models? Let's chat.